the final topic in this unit on working with functions is how to find the x and the y intercepts for functions. So the first thing, I guess we should write down what those are. An x-intercept happens when the function crosses the x-axis. And the way that you do that is you solve where the function is equal to 0. So when does the function have that y value of 0? For the y-intercept, get that written down there, y-intercept, that happens when the function crosses the y-axis. That occurs when the x value is 0. So you are evaluating the function at 0. So these two things, these facts, you need to know that from this point forward, because in the next unit we're going to be doing a whole bunch of sketching of functions and having the intercepts. Those are easy places to get on your graph to help make sure your picture is correct. It's also a fundamental skill for calculus going forwards, trying to find out where functions cross the axes, and then you're going to use the same sort of idea to find places where it turns and places where it inflects, etc. So just baby steps. We'll try some y-intercepts first. So first function will be f of x equals 2x minus 3 squared minus 5. All right, now take a minute, look at that, and decide what shape it is. Hopefully you're seeing a parabola. It's this kind of function. All right, so if you're after the y-intercept, what you're going to do is you're going to evaluate the function at 0. So f at 0 would be 2 times 0 subtract 3 squared minus 5. Following our order of operations, I need to simplify the argument first. 0 minus 3 is negative 3. Once the argument is simplified, I execute the function. Negative 3 squared is 9. Now that the function is executed, I go through and I apply the external modifiers. 2 times 9 is 18. 18 minus 5 is 13. Therefore, the y-intercept of f of x is 13. So if I were sketching this thing, at 13 on the y-axis, this parabola has to pass through it. So it either looks like that or it looks like this, one of the two. Okay. So for this example, I've got a radical. So you need to take a minute and think about what that looks like. And it's a little nub, and then it takes off like so. So if we're trying to do the y-intercept of this one, I'm going to evaluate the function at 0. So it'll be negative 3 square root of 2 times 0 minus 8 plus 1. Oops, that shouldn't be there. So order of operations, I need to simplify the argument first. It's negative 3 square root of 0 subtract 8 is negative 8. Negative 8 times 2 is negative 16. And that's kind of exciting because 16 is a perfect square, but you can't square root a negative number. That's forbidden. So I attempted to find the y-intercept of this particular function, and I came into one of those situations where it doesn't work. So what does that mean? Well, this is telling me that there is no y-intercept. So you see why you have to be careful about this, because if you were trying to find y-intercepts of this and you just fudged that and said, well, whatever, I'll call that 4 and go on, you would have found a y-intercept when one does not exist. And then you would have tried to sketch it with that y-intercept in the wrong place, and you would have wondered why your sketch wasn't working. So if this happens to you, check your numbers, right? I'm certain that this is negative 16. Which means this doesn't work, which means there is no y-intercept. So if I try to sketch this thing, and it's not allowed to cross that y-axis, it's either over here so that it doesn't reach it, or it's, you know, underneath somehow, or it's been flipped to open up that way. It's one of these four things. I'm not really sure which one, unless I look at the rest of the translations and transformations. It ends up being this one, but shifted up a little bit. You can see that it doesn't quite make it to the y-axis. Alright, so here I have a base 2 logarithm, just for some excitement, and I'm going to try and find the x-intercepts. In order to find an x-intercept, I have to solve where the function is equal to 0. So 0 is -3 log base 2 of 4 times x minus 6 plus 12. So I have to kick this 12 over, that would be -12. And then I have to divide by -3. -12 divided by -3 is 4. You break a logarithm base 2 with an exponential base 2, so this side will become 2 to the exponent 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power 4 would be 16. Divide both sides by 4. 16 divided by 4 is 4. Add 6 to both sides, I get 10. Therefore, the x-intercept is at x equals 10. Alright. So, if I were to sketch this thing, whatever it looks like, it would be crossing the x-axis in exactly one place at the point where x equals 10. Okay, so here we have an exponential. I'm going to try and solve its x-intercepts. So to get an x-intercept, I'm solving where this thing is equal to 0. So I'm going to set it to 0 for the x-intercepts. Minus 2 plus 1. I'm going to kick the 1 to the other side. Instead of dividing by 2, I'm going to multiply both sides by 2. 1 times 2 would be -2. So to break an exponential, I need a logarithm. If the exponential is base 3, then the log I need is base 3. So this will become log base 3 of -2. But when I try to do the log of a negative number, I remember from the last section that that is also forbidden. So I check back through, make sure I didn't screw up the negatives. A positive would be a negative over here, negative times a positive is a negative, and then log of a negative is still forbidden. Therefore, there's no x-intercept. So this thing, if you can recall what it looks like, exponentials have that long tail and then take off. This thing has been shifted right 2 and up 1. So on the x-axis, it rides, it has its horizontal asymptote at 1. So where does this cross the x-intercept? It does not. And your algebra has told you that. So we're going to try and find the x and y intercepts for this particular exponential function. So as always, we get the y-intercept first, which you do by setting x equal to 0. So m at 0 would be 1/5 of 2 to the exponent 1/4, 0 minus 3 minus 6. Order of operations says I have to clean up the argument first. So 0 minus 3 is -3. To do 1/4 of -3, you're going to do 1 times -3 divided by 4. I'm just going to write that down so that you can all see what I'm talking about. So any fraction when you're evaluating it, you multiply by the top, divide by the bottom. So 1 times -3 divided by 4. Now if you work that out, that's 1 times -3 is -3. And -3 divided by 4 is -0.75. So I'm going to have to pull out a calculator there. Oh, that's a lovely thing. And I'm going to need 2 to the exponent -0.75. And if I do that, I end up with 1/5 of 0.5946 ... Keep 3 or 4 decimals just so that we don't get too much rounding. To finish, I need to work out this fraction. So just like up here, 1 times this divided by 5. Gives me 0.1189 minus 6. So just to finish, if I subtract 6 from that number, I end up with -5.881 if we're rounding. So if you were trying to sketch this thing, it would cross the y-axis at -5.8811. We're going to get the x-intercept as well. In order to do that, I'm going to have to set the whole function equal to 0. So I'm going to put my 0 here. And I'm going to have to use the algebra process, undoing my order of operations in reverse order of what was done to it. So that's going to get done first, then that, then this, then that, then that. So this is the last thing I need to move. You undo subtract 6 by adding 6. So 0 plus 6 is 6. This is telling me to multiply by 1, divide by 5. So I can undo that by multiplying by 5 and dividing by 1. Uh, 6 times 5 is 30, divided by 1 is 30. Now, this next part you're just going to have to take on faith. I have to break an exponential with a logarithm, and I would have to use a log base 2 because I have an exponential base 2. But your calculator likely doesn't have a log base 2 button. So we're going to have to use a trick using the log base 10 button. So I'm going to introduce log base 10 onto both sides. And you're going to do it too because you trust me. Now, through the sorcerous properties of logarithms, what that allows you to do is to drop this thing out of the exponent. So I have log 30 equals 1/4 x minus 3 log 2. And that's just a number. So if you have a number that's multiplying a thing and you want to break it, you need to use division. So I'm going to break this from the side by dividing by log 2. There it is, divide by log 2. So I'm going to type this directly into my calculator. Log 30 divided by log 2. If I can get the marker to stop rolling. Log 30 divided by log 2 equals
4.9069 if I round. So this nonsense here is worth that much. And I still haven't dealt with this yet. So I'm being instructed to divide by 4 here. So I break that by multiplying by 4. 4.9069 times 4 gives me 19.6276 if I round. And I finish off by adding 3 to the other side. 22.6276 equals x. So this particular exponential is going to hit the x-axis. It's going to yes, it's going to hit the x-axis when x is 22.6276.